All right, so in this problem, we are doing a revenue problem. A company sells jeans for $40 each and they sell 2,550 pairs. And for every $2 price decrease, they sell 75 more pairs. And we basically have to find the maximum revenue and the best price for, or the optimal price for the company to sell the jeans for. So anytime we get a revenue question like this, our revenue equation is revenue equals price times number of items. In this case, the items are jeans. And this is always a factored equation. So R of X equals, my starting price is $40. And my price goes down by $2 every time. So minus 2x. And x is the number of $2 price decreases. That is my equation for my price right there. And I'm going to multiply it by the number of jeans sold. Initially, I'm sold 2,550 jeans. And this value goes up by 75 every price decrease. So again, X is just the number of price increases or number of price decreases. In this case, number of $2 price decreases. Okay, now in order to find my maximum revenue and the optimal price, I need to find the vertex. And the best way to do this is to find the x-intercepts and do the midpoint method. I'm going to make this equal to 0. I'm going to solve for my x. So 20 equals to x is my first solution. My second solution is negative 34. Remember, this is not the price, this is the number of price decreases. So in order to find the price here, I'm going to sub in 20 into my price equation. Oh, well, actually, these are the zeros. I still have to find the vertex. So I'm going to do my midpoint method to find my vertex. I'm going to do 20 plus negative 34 divided by 2, and this is going to give me the x value of my vertex, which is basically negative 7. So in order to have an optimal price, I need to have negative 7 $2 price decreases. I know that's confusing, but let's actually find the price using the price equation. It's going to make things simpler. So my optimal price is just 40 minus 2 times negative 7. And that is $54. So if I sell these jeans for $54, I will make maximum revenue in this problem. Okay, how many jeans are going to be sold at this price? Well, if I want to find the number of jeans or the number of items, whatever you want to call it, it's just this equation right here. So 2550 plus 75 times negative 7. And this is going to give me 2025 jeans. If I want to find the maximum revenue itself, I can sub in the x value of negative 7 into this equation, or I can just multiply these two over here because that's going to give me the exact same value. And it's a lot easier and quicker. So that's 109,350. And last thing I can do is I can graph this relationship and show you exactly what everything means. So in revenue questions, you can have positives and negatives because your X can be positive or negative depending on the number of price increases and decreases. So your X is just the number of $2 price decreases, and your Y-axis is just your revenue. You cannot represent your price or your number of items on this graph. And then we know that we have negative 34 and positive 20 as our x-intercepts. And we also know that the max revenue is 109,350. We know the x value of this is -7 over here. So this is what our graph will look like in this situation. This is actually not the y-intercept. This is the point here. So I know my graph is a bit off, but I haven't drawn my scale so well, but that's not a y-intercept. That is just the y value of the max revenue. We could find the y-intercept if we want, but basically the vertex right here is -7, 109,350. If we wanted to find the y-intercept, we just sub in an x value of 0 into this equation, and we will get 102,000. So that is the y-intercept.